Ah yes, the Stirling engine. You gotta love its simplicity. I love it because it's actually a thermodynamic system. It's basically running on the ideal gas law that we learned in, what was it, high school, chemistry, physics, something like that. It's actually, the Stirling engine's got its name from a guy by the name of Robert Stirling, who kind of perfected it in 1819, got himself a patent. He's actually a Scottish minister. He's kind of tired of all his parishioners getting killed by the internal combustion engine. This is an externally combustion engine. We blow out that flame, which is basically just a little alcohol lamp that's heating up this side of the engine. The Stirling engine runs on hot and cold phenomenon, whereas you got hot over here, and these fins give this aluminum housing the chilling effect, and it will finally give it up. Temperatures are not differential enough. So the gas that's in here heats up in this hot chamber, and this piston right here is the one that's actually pushing on the flywheel and giving it all the power. We call it the power piston. The flywheel is then telling this little persuading rod here to move this thing called the displacer back and forth in the hot chamber. So right here you got all the air on the hot side of the chamber, and when the flywheel moves over to here, the displacer has pretty much pushed all that air back into the cold side. This displacer, it's not sealed at all, and air is allowed to flow back and forth between the hot and cold side. There's a decent drawing on the internet I got here showing that displacer, the air gap, a hot side, a cold side, hooked to the flywheel, moving back and forth. That pressure that's built up by the hot air pushes on this thing called the power piston, and really gives that flywheel the momentum. Is all coming from the power piston, and then the flywheel is giving it back to this displacer. I kind of like the stages of the thing, and I got this drawing here, hot side, all the air is getting heated up. When gas gets hot, it expands because it's getting excited, and the air is allowed to push on this power piston, which is pushing on the wheel. Then as the wheel's moving, the flywheel will then begin to get pushed back into the chamber there, and the air will then all be moved onto the cold side, and when a gas gets cold, it contracts, and it actually lowers the pressure, and it actually starts pulling the power piston back, so you get a stroke going that way, both directions. After the volume in the whole system is decreased to its minimum amount, that flywheel is now going to pull that displacer, and all those cold side molecules are going to be moved into this, rushing into this hot side, where guess what? They're going to get heated, expand, and start pushing on that cylinder again. That system right there goes through these 4 pressure and volume steps, and scientists love to do charts. So this is volume on this side, high to low, pressure going high, and you can see the volume as the volume is basically that power piston moving in and out, and the pressure is basically given up by temperature. As gases get hot, they increase pressure. As gases chill and get cold, they contract, and you get less pressure. That's the Stirling engine explained with science.